In the first video, we talked about Lee Boycel, the founder of four-phase, as well as we talked about the architecture behind it, the AL1, and we also talked about this computer here, the Model 470, which was one of their most popular products to be available, and probably one of their most expandable upwards and downwards. If you haven't watched that video yet, I strongly recommend you do. Look down in the description and you'll see more about it. Now, like I stated, 470 merely defines one particular product. If you went up or down within four-phase's product line, it could be a 430 or a 450. Or if you go towards the high end of their product line, the 490. Now, the 490 is a little bit more than just a souped-up AL1 that's inside the same 470 cabinet. It's its own external box. But before I can talk about the expansions, which is this entire video here, I want to talk about how you added expansions into here. Cabling, primarily. Now, like I had covered back in the first video, this section of the machine is I/O expansion. So this is where all of your option cards would go into the machine. There is by no coincidence here that there is a giant metal bridge that goes over top of the console distribution board, and on the back here we have a set of these zigzagged threaded holes for some reason. This is all for cable management, and I have a fair number of cables here to show you. So this cable right here is for the bus expansion board. This one here that I was talking about that I mentioned, I don't actually have the expansion backplane for it. So that would plug into there, and it routes across, and you have this long ground strap which actually runs out, and then you would simply attach that with a screw there. So now you have a shielded cable that's shielded on this end, and you have protection going all the way back over here to the connector, which plugs back into there. Another cable that I also have is this one right here. This one connects to the tape formatter from the tape controller. And as I remember, that's this one right here. So it's fun with these. So what you're looking at here is one of your typical blue plastic edge connectors with this sleeve that goes over the top. And that's just so instead of having it go straight out, it can go and be directed off to the side. Someone's drilled a hole in this because there's so many wires. This isn't big enough. But this would plug in there, and that would go out to your tape formatter. This one has the ground strap broken off on it, but again, it just sits in that cable tray. We also have another peripheral expansion, and that is called the NP-80. We'll be talking more about that within this video. And it, surprise, has its own cable as well. And as we mentioned, the NP-80 expansion is right here, if I can get it in. There we go. That also has its own dedicated ground strap, so that would also attach onto the grounding here for bus shielding as it ran between cabinets. And two more cables here. Now, first off, I want to make a correction that I made from my first video. This board right here, I mentioned that I only had two halves of it, the 8437 controller 1. This is not a disk controller. The 8437 is an asynchronous serial controller. There's two boards that make up the set. This is probably one of the most intelligent serial ports I have ever seen to have its own microprocessor and dedicated RAM. But it would actually be two cards that go in there, and then I have the cable for that as well, and that just simply plugs one in there, and another one, you didn't see that, okay, which plugs in there to the other neighboring card. And then you would have a cable that would go out, and it would go out to your physical 25-port serial port. Unfortunately, in this case here, well, this cable's really rough, and someone's actually sliced the end off of this. Thankfully, I do have the wiring diagram for it, so okay, I can rebuild this cable. I can make new sleeves for this. This is not necessarily a problem. What's more of a problem with this card is the fact I'm missing half of the board set. So no serial ports. I'm just going to put that somewhere where it won't get broken more. Lastly, if all these cables weren't crazy enough, the 490 CPU expansion. So this has its own dedicated board here that is just simply a bus converter for what's about to happen in here. It has two edge connectors sitting on top of it as well. Now, we've already established that Siemens 4-phase really like to do their cabling like this. For the 490, completely different cabling. This here is kind of regular ribbon cable. It's a jacket that's itself shielded that goes over 3M ribbon cable, which itself is copper grounded and jacketed. It's a very heavily shielded cable compared to everything else. You can see here I've already marked pin 1 as well as which connector it plugs into on this card here. And you're just supposed to plug that in, run it through the cable guide, and then plug it into the 490 expansion chassis. These connectors on the end here, these were fun. So when I got this and I was cleaning them, it looked okay. And then the first time I plugged them back into the board again, almost all the gold fingers broke and fell out of it. It was so horribly corroded and weather damaged, I had to replace them. I was able to find replacement panel mount ones, and they're fine, but what I found was that after I had trimmed back the corrosion that was in the ribbon cable and then tried to crimp it again, the ribbon cable had shrunk a little tiny bit so that some of the pins were shorting out against neighboring pins. My solution to that, without having to get a new cable, this shielded cable is not cheap at all, is I went at it with a heat gun so I could massage it back the like 1/8 of an inch it needed to be, and then I was able to then put it into a crimping tool, crimp it back together, and there we go. These cables are ready to go once you plug them in. Now, because I finished off this here with the 490 CPU expansion, let's start with the 490 CPU expansion as our first peripheral cabinet. Now, let's keep in mind that this came out a fair number of years later after the 470 came out. So it is simply a CPU expansion and accelerator. But as a result, compared to how fancy the 470's front panel looks, this doesn't really have a front panel to it. Now, it says quite proudly right here, System 490. Doesn't even have a label for this red light here, which is just the power button. Very standard case. We can see that we do have fans on one side here. It just simply blows straight across the inside of the card cage to either side of the rack. On the back of this here, we don't have anything fancy. Like I said, we only have 2 ribbon cables that go to this thing. There's 2 places right here for those ribbon cables to connect. Yes, I had to end up marking those as well. No other fancy expansion or anything. It's a nondescript metal panel. Even on the top of this thing here, it just gives you a warning saying before serving it, make sure you extend the legs of the rack, and also that this thing is quite heavy. It also contains a ferroresonant linear power supply, so that is fairly par for the course, so that's why it is so heavy. But beyond that, everything inside of this thing, it's fully loaded. So I flip down the front door here, and immediately there's our power switch that's just kind of hiding over there. And there's our power light, like I was mentioning. And here are all the boards that are inside of it. Let me just get this a little bit rearranged so I can pull the cards all out. I don't have to stand way off to the side like I was in the last video. Now, like I said, this here is equipped with all of the options and boards that's supposed to be in here. So slot 2, ironically slot 1 is not used in this for any reason, is the 470 memory interface board. Slot 3 and 4 is the 2 halves of the CPU. The memory map exists in slot 5, and we have 2 boards of memory that are existing in memory slots 1 and 2. I've also gone for the benefit of all of us, unseated these boards beforehand. They're very stiff in their slots, and part of that is because they were out in the weather. The connectors were quite badly corroded. You'll probably see with some of the RAM. With the memory interface here, keeping in mind that this was later on in the 1970s, we've begun to see more intercell programmable logic inside of this. We're also seeing on all 4 corners here these Sprague 50 microfarad, 50 volt epoxy capped capacitors. All of the ones that are in the 470 and all of the peripherals were bad. I've already done a video about this once before. Here's another bag of 50 of these blasted capacitors just to get this all properly recapped. Because when I was doing testing, I thought I might as well leave these in, and no, one shorted and exploded. Otherwise, we're still dealing with a lot of standard off-the-shelf logic, and it's a 2-layer printed circuit board, and there's really not much else to it. It is not using the standard interface that we saw before if the size of the cards tell you anything. But we still have, on the very far end here, a header which is being used for debugging and testing purposes. I also have some more of these early LEDs that are sitting here to give me various diagnostic states. Now we can move on to the CPU. I don't know what it was about the 1970s, but much like how we say artificial intelligence right now is all the rage and everyone's doing it, and back in the late 80s and the 90s, people were saying how digital signal processors were going to revolutionize everything, and then it kind of came and went, and now we just casually use them everywhere in our applications. Four-phase was no exception. This is part one of the 490 CPU. There is a significant amount of intersil programmable logic living over here. And then we have a whole bunch of bit slice. What were these again? Yeah, this is AM2900 series 4-bit bit slice chips all along here. And that is what is making up the emulation of the original AL1 CPU. It's fun. Hewlett-Packard did this with the HP 45. There was a bit slice processor option, and the bit slice processor was significantly faster than Hewlett-Packard's own custom CPU design in the 1970s. So like I said, like everyone was just adapting over to bit slice before settling back down and going back to more standardized microprocessor designs. You can see again here, it's green on this side, and over here it begins to brown out again. That's just because of the ventilation holes on the one side of the cabinet where the sun was blasting in, and there's some UV damage. I also run into chips like this where I can see that there is rust forming on the legs. For chips of this era, that's typically not a good sign. So there's more than likely more than just recapping that I'm going to have to deal with this board. The other half of the CPU board is more of the same. Intersil programmable logic living over here. 4 more of these terrible 50 microfarad 50 volt capacitors. This one here is actually corroding from the inside out. So this one's really bad. I bet you money I put this into a cap tester, it's not going to be a capacitor at all anymore. It may very well now have just become a resistor. And we still have an edge connector on the end here for diagnostic purposes, as well as I have a toggle switch here which is off and DGLP. My guess is that if I switch it to that, it puts it into a diagnostic test loop or a known series of routines that it continues to cycle through over and over for testing purposes. Now we go to the memory map, which is a lot of RAM here in one style of packaging. Again, we do have a switch here, which switches between off and RMAP, and then we have map PE. Presumably that means parity error. These are not sanded off chips. If you can see that, they're like, this is not sanded down to say the least. But it's actually all weather damage. The paint's come off of them. I really can't tell what each one of these were. Like even the trick of licking your pinky and then just wiping it, like I can't see exactly what these are. It's a good thing that the schematics for this are available, so I do have the ability to go and double check on there to see what's on it. But other than that, there's more rust that's showing up on a lot of these ICs, which is going to be nothing but problems for me if I ever try and get this working. And again, it's dirtier on this side here because the fans would have been over here. This side over here would have been exposed to the weather when it was poorly stored. So I'm expecting to see a lot more damage on this side than this side. How much of the RAM is actually good, heavens knows. And speaking of RAM, oh my goodness. Okay, so the next two boards are exactly the same. Let's keep that in mind. But there is a lot of RAM on this. Every single one of these is one of NEC's UPD 401, sorry, NEC UPD 410D. These are 4096 by 1K SRAM chips. These are all socketed. For the love of God, I'm happy these are socketed because I'm sure these are going to cause problems. And like I mentioned before, this side is quite clean. This side here exposed to the elements, the first row of chips all have rusty legs. And there's more of these capacitors here to have to deal with, but thankfully this time they're all clustered over to that side. This board is heavy. It is also, again, a double-sided printed circuit board. But again, this is showing that by the end of the 1970s, Four-Phase was no longer manufacturing their own semiconductors for the RAM purposes here. They were just phoning it in to somebody else to sell them. And in NEC's case here, NEC had a bit of a reputation through the 1970s of taking other people's designs and then reverse engineering it and then doing it themselves and selling a clone of it. I'm pretty sure this RAM here is all a clone of some other type of RAM that was available at the time. It's also worth pointing out, as I pull out this last one here, and like I said, that it's a duplicate of what we saw before. 4-phase does leave test leads up here, so I can see someone's already marked in saying +5 ground and +12. So someone's been testing with this already. And again, this is just fully populated with NEC chips. Is there really much else to say? This is a CPU expansion for you. So now we know why it was so heavily shielded. We have a full bit slice processor that's doing emulation of the AL1 and a ton of RAM. I am not going to count this all at the top of my head here. I'm assuming it's a lot. I am also assuming that it is not being addressed in your usual 16-bit. Remember, it's a 24-bit machine. So I would assume that each board is at least 128 kilobytes in size. If someone else stops the video and just kind of reads this, just leave me a message in the comments there. Sorry, I'm not going to put a text box here at the time. Oh, I totally forgot about that. Because this thing is so heavily ventilated, hiding inside the cabinet, even behind the power light there, is another light that says thermo cutoff. The idea here is that with all of those semiconductor SRAMs in there, this thing's going to be getting quite hot. So the idea is that if this overheats, there is a temperature sensor in here which shuts off your CPU. Presumably that also means that your system crashes, but okay, you're running in an air-conditioned room anyways. Hopefully you never see that light turn on unless you have a fan failure. Now, after I've shown you the 490 CPU expansion cabinet, you may be confused as to why I have something very similar looking sitting up here again. If not, you're mistaken, it's just the 490 cabinet again. This is not. This is the NP-80. It is an intelligent peripheral expansion device. It looks exactly the same. Same two fans, AC. It has the same linear power supply inside, and even the front is just as boring looking, but now it no longer says System 490, and instead of a power light, I have a power light and another light here that says halt, push to reset, and it is a physical button. This here is, well, I think the easiest way to explain this is that, you know how there was a time in like the late 90s, the early 2000s where playing a DVD meant that you needed either a video card that supported MPEG-2 decoding, or you needed a whole extra PCI card that would handle the decoding of it for you, rather than completely hogging up the CPU. This is doing somewhat of the same thing. It's a coprocessor, specifically just for the peripherals. So instead of the CPU having to handle all these extra tasks and interrupts and data requests, it can have a simple set of commands that it sends to the NP-80 over that much simpler expansion cable compared to the 490 cabinet, and it will handle all of that internally into this cabinet. And because there's now a lot of peripherals that are being handled by this box as opposed to the CPU, that offloads a whole bunch of connectors that the main CPU cabinet, or the 470 in this case, would never need. So as I spin this around, we can now see, oh yeah, there's much more on here. There's so much more on here. There we go. I really need that block of wood or it really scratches the heck out of this desk. We have our main connection back here to the CPU, and I know it's the main connection back to the CPU because the one down below it is all like it's begun to get bleached by the sun and the weather being exposed to it. This one still had the cable plugged into it when it was found in the pole barn, so as a result, it doesn't have as much weather damage attached to it. And then you have these things right here. So these are the same stupid Winchester connectors I was talking about before. This time, however, I got very lucky. This is a little box that I got at VCF West last year in the free pile. And it is just Winchester connectors of the same size as the smaller Winchester connectors on here. So I am able to at least make adapters or cables for those, for whatever that is. This monolithic connector, on the other hand, I don't have a Winchester connector for that. But at the same time, I don't even know what that's used for. What I do know what was used for what on the back of this here is that we have spots which look like they would be more 25-pin ports. there was more communication options that were available, and instead of having them sitting inside the 470, you would have them inside of the NP-80. Now, let me do the same thing as I did before, and I'm going to spin this around, and I'm going to slide this out here. But before I completely get it out of the way, I want to show off something inside of it. For that, I'm going to need a screwdriver because it has a single captive screw. Because this is an intelligent controller, it's obviously going to have its own microprocessor inside of it. It also has its own front panel as well. From this right here, not only can you reset the CPU that's in here, you can toggle in various states and diagnostic routines just like you could with the front panel on the 470. Even for this here, again, manual mode, I can switch what type of boot mode I want, reset, I can look at various registers. It's a fully featured front panel. It actually is held in, and the CPU board is hiding behind here. It is wobbly, sorry folks. If I take one screw out here, because I only have one holding the panel on, this metal cover comes off, and then the front panel pops off, and that reveals the CPU board underneath there. So now let me get this just tucked away over here, and we'll pull the boards out of this here, and we'll look at those. There. And like I said with the previous 490 cabinet, I had to go off camera and unseat every single card in order for me to do this, because they're very stiff in their slots. But let's start again at the very top here, and like I said, this has a processor in it. Surprise! It's more bit slice. That makes 3 major bit slice microprocessors we've had to cover. And at any time, there's 2 of these things running inside of a 4-phase machine. These are all N3002N 2-bit bit slice microprocessors. Now we're also getting to see more advanced logic. What is the date codes on these? This is 1984, week 49. So this is very late in the life of 4-phase systems. Like I mentioned also before, and like we saw with that plastic cap, the weather has not done very nice things to anything we've seen today. These here are those neat little intelligent 7-segment LED displays. You cannot see it from the angle right here, but these are absolutely, they're roached, they're cracked up, they're split. When I powered this system up for testing, the segments didn't even work. These are completely dead. So I have to go and source replacements for those. I know I can get those quite easily. I'm pretty sure I have them already, and I'll switch those out. There's more intersil logic that's hiding around over here, but the rest of this, again, 7400 logic. Surprisingly though, this is not using those stupid Sprague 5050 capacitors I was complaining about earlier. Someone's gone and recapped this at least once before already. 2-layer printed circuit board, very well laid out in its usual arrangement. And as you can see here, this side looks a little bit different from this side because, again, exposure to the elements has meant that this side of the board has seen a lot more weather than anything else that was inside of this cabinet. The next board in here is because there is no RAM that we saw on the processor board, is just a memory board for the system. So this is using semi. I think this is on semiconductor actually. Same thing as before, 4096 by 1 static RAM. This time, not NEC clones. These ones are date coded from 1978 and 1979 and a little bit more intersil logic. And they're those stupid Sprague capacitors again. But there's 1, 2, 3 of them, and then this one's been replaced once before in the past. So I'm just going to go and just carpet bomb replacing all 3 of them. And like I mentioned before, these chips over here kind of have rusty legs. Thankfully, it's not the intersil logic. So those may have to be replaced, but the intersil logic was on this side. And that is actually not weather damage, so I may get lucky with this. This cabinet here, by the way, it doesn't just take 1 memory board. There is an option here for 2 memory boards that were available, if you can see way the heck over here. And below that is the disk controller. Now I'm being correct. If you had yourself a Diablo Series 30 drive, you know, the same thing that Xerox Alto used, a number of other manufacturers and vendors used with their computers, that was a 2-card set that went back into the 470 cabinet. But if you were using something such as SMD, you would get this board here, which was your disk controller. And I'm thinking that's probably the connectors with the Winchester plugs on the back of this cabinet here. This is not for anything very similar to the Diablo drives at all. Instead, it's going to be a washing machine sized pack loading drive. Absolutely none of those were found when this system was located, so that was long gone. But I do have an SMD controller for this, which is interesting because I'm curious exactly what variant or specification of SMD this is. I might have spare smaller control data SMD drives available. I'd have to do a lot more research on this. It's cool also, there's been some bodges being done here. So this is one of the first real boards I'm seeing bodges on, and it has these little tiny sticky pads crossing over to hold them down. This one's popped up, but also this one's been recapped once before, and you can see the weather damage on a two-sided board here. This here, you even still see there's flux residue from something happening over here. That's interesting. And other than that, this is kind of an empty case. There's only one board that's left in here, and that is the 4-phase 470 interface board. This thing right here. Little bit of interstill logic, and again, it's all 74 logic. This stuff here is all dated 1984, 1983. So this probably got swapped in as some sort of upgrade or replacement when the processor board got switched out, because we noticed that those there were using later date codes compared to the RAM board, which is probably original to this NP-80 cabinet. And also, you can't see it because it's off camera here, but you're not missing much. This also has a light indicator for a thermal cutout. So if this here overheats, it shuts itself down and the computer just probably completely freaks out because all of my peripherals just disappeared. But I'm assuming it's not as catastrophically crashy as when you lose your 490 CPU expansion. Finally, the last item that I have that's rack mountable and also related to 4-phase systems wasn't manufactured by 4-phase at all. It was a component of one of their accessories, the tape drive. 9-track tape drives were available for the system, and this is part of what made that all work. This was manufactured by a company called Wanco Incorporated, and Wanco made a fair number of tape subsystems, not just for 4-phase, they were fairly universal. Wanco actually was around long enough that they also made floppy disk drives as well. And to no one's surprise, 4-phase systems did for a period of time have floppy drives available for their systems, so that much like with the System 32 being able to take in data from key to disk systems, I'm assuming the 4-phase systems could also be accommodated to input data in that format for key to disk for pre-processing and then sending off to actual IBM systems for the final database management and data processing. But this box here is kind of what we call in the telephone industry a demarcation for the end user, which is to say 4-phase only goes so far, and then after a point, it's no longer 4-phase's problem. An example of this I can have is simple, is this IBM NT1 ISDN network terminator. The phone company's ISDN comes into this point, it terminates at this point, and all the user equipment is on the other side of it. This box here is not the tape controller. It is simply preamplification, buffering, and all the smarts the tape drive needs in order to operate. The tape drive itself may have circuit boards inside of it, but that's like primary filtering, the read control circuits, the right head amplifier circuits, and motor control, obviously. And this here is pulling all the strings in between. And if I spin this around, it's significantly lighter than all the other cabinets as well, I want to point out. So we've already talked about this cable here, which comes from the tape controller in the 470, and that just simply plugs in right there. And now it can communicate with the tape formatter. On the other side of the formatter, it's Wanco's problem. So we have kind of this mess here. It doesn't look anywhere near remotely like what 4-phase had for cabling standards. So it's kind of like zip-tied, loose wires, no real protection on any of it. And that would snap in on that side like that, and this would run off to the single tape drive that was in the cabinet. Like I mentioned before in the first video, This did have a tape drive when it was first discovered, but because the weather was so bad, like we saw with the boards, everything's rough, the tape drive, and notably the tape path and tape heads, were just a total write-off. So that wasn't savable at all. So I am looking for a Wanco tape drive to make this all work here, but I'm not going to elaborate on that yet. So, with that being demonstrated, what's going on inside of this here? Well, on the front of it, I have control for 4 different tape drive channels, so 0, 1, 2, and 3. These here are red and green LEDs in combination. So what's supposed to happen there is that I can select which drive is going to respond to which address. And if I open the front door here, well, we have a power switch right there, but we also have the various boards that control the read and write logic. Again, this is not 4Phase's design. So as a result, it's both enormous and it's also kind of a mess. This is all hand-drawn traces inside of here. These are sitting on top of mezzanine boards, which are plugging into dip sockets along the edge right here. And again, it's its own weird proprietary backplane that's going on right there. This wasn't 4Phase's problem. But we have, for example, this board says it's the read track detector, read logic. Is this one here? Yeah, read logic, read logic, read logic. And we have little tiny paddle boards that are sitting right over here. The right control board is the exact same thing. It just has the address select switches on top of it. Other than that, this would all go into a single rack. You'd have the tape drive, you'd have the disk drive, and this would make up your full system. For the end user, or the people who are going to be using the system presumably as a timeshare or in a multi-user executive environment, that is where the terminals come in. Now, like I mentioned before, the terminals that 4Phase used were very, very, very special. Now, that's not to say that IBM and Wang and a couple other vendors were doing their own thing, but 4Phase was especially special and seemingly quite cursed. A composite or a derivative of composite video signal leaving the computer going out to the terminal, with a bidirectional data line also running along next to that, which is controlling the keyboard so it can get key entry in back in the vertical blanking and then sending like feedback to the user through the same lines. It's not like serial in any sort of way. And with the VT100, it's a bit more advanced. You unplug the serial port out of a VT100, whatever was last displayed on the terminal stays on the screen. You unplug a 4Phase terminal, you lose everything. The video, the keyboard, everything is just dead. Now, normally when I try and find terminals, I run into a bit of a problem. This is more an increasingly bigger problem that started maybe about a decade ago, but some people really like the devices that they type on, the keyboard. So as a result, there's a lot of people who only really just want the keyboard, and some eBay sellers and the likes like to simplify things by selling the terminal as one object and as the keyboard for another, usually with a much higher price. And I don't like paying twice as much for a terminal and then for the terminal keyboard. And ironically for 4Phase, it's been kind of the opposite. Usually I criticize just like how many terminals show up with the keyboards just completely missing entirely. And it's been not the same for me. So understand what I'm getting to when I pull this first keyboard out. You see, stuff like this has been showing up, and I have 3 keyboards for these machines. Just the keyboards. This one here, kind of comedically, someone retired and they took the old 4Phase terminal keyboard, they spray painted it gold, they spray painted the keycaps gold. Don't worry, I'll show you that one in a moment. And it even says retired December 91. Now, was that the retirement of the computer or retirement of the administrator who maintained this 4Phase system? We'll never know. The keyboard itself is actually really well made, like the whole case. That is metal. That is cast aluminum. This is even the top piece here. That's all aluminum. This is a very heavy keyboard. And, well, there's your one connection right there. It's a keyboard. Nothing special about that. But I mentioned I have 2 others here. So if I pull out the keyboard that I took out of it, this is the one that's covered in the gold keycaps and all that. This is going to be fun to clean off. This here is more evidence of 4Phase's own semiconductor design. So the key decoder and transmitter receiver is right here, and the multiple digital lines that are traveling in are coming in through here. Now, 4-phase could ask if you would like to have your keyboards configured in certain ways. So if I put that one there, this is the third keyboard I have here. So notice how some of the keys are arranged and labeled. And then I'll bring back our gold retirement special here, and you can see that some of the keys are labeled differently. And that really depended on what task you were ordering this terminal for. Data entry, key to disk, or word processing, or one of the likes. They had different keycaps that were available. I don't like talking details about these keyboards, usually because the wrong people are often listening, but I might as well explain it because there's a bit of a story here as well. So this here is using little vertically standing glass magnetic reeds, and when you push a key down, a magnet is causing that reed to close, and that's generating the keystroke. That seems like a really cool idea, and when I open the thing up, like, it does look quite pretty inside, but I was talking to one of our unnamed engineers who said that it did seem like a great idea. They were terrible, and they would constantly run into times where typing too hard or rough handling would cause those little tiny glass reed switches to break. Even in this one here right now, actually, this had at least 7 different reed switches that were broken that I was able to replace. They're simple reed switches. Like, I can take them out of cheap AliExpress orders, like little door and window magnetic reed switches and stuff like that. Very easy to get your hands on, but kind of a pain to solder back in. So I understand what he was getting for by saying that they were cool, but they were an engineering and repair nightmare to them. But surprisingly then, that means that I have no terminals, so I can't even demonstrate to you, even if I ever got that 470 system working. I'd have no visual way to show you anything working on it. And that brings me to the last section of this video here, my plea for help. All the computers from 4-phase systems are essentially forgotten machines. How many people went into this video series aware of who 4-phase was? How many people knew the history behind Lee Boycell? How many people knew these computers or even that logo? The reality is that 4-phase rose to prominence and fame in the 1970s, and by the middle of the 1980s, they were completely irrelevant for reasons I will explain in a little bit. But that meant that, much like we saw with that gold-painted keyboard from 1991, by the 90s, 4-phase computers were already being phased out of service. By the year 2000, Y2K probably culled a lot more machines. Today, I can find only the existence out of those thousands or even tens of thousands of machines that 4-phase systems built over the years. Less than 10 exist still. There are more Apple I's, functioning Apple I's, than there are 4-phase computers in any condition left on the planet. Between me, the Museum of Information Technology at Arlington, another private owner, and one that's on exhibit in the European Union, that's it. Those are all the systems that are left. What happened to them all? What do you see here? 4-phase systems, in their most prominent days, manufacturing their own chips, were using white ceramic with gold-rich chips. I'm sure, like, back when these first units were being scrapped, they were being salvaged for their precious metals. Today, it's more of a case. I've seen this stuff show up on eBay before over the last 2 years. And every single time, they're not selling the board because it's a 4-phase relic or an artifact or part of the computer. They're selling it for the scrap gold. And I'm talking about not just hundreds of dollars. I've seen them sell for thousands of dollars. And I'm not saying that's probably what the fate of all these should be, but what that's resulting in is that for me to get replacement components, much less boards for these machines, is very difficult because I'm up against people who, through whatever marketing and sales figures they have, you're buying scrap gold boards on eBay at high prices and markup, and either then processing it yourself or accumulating it into a larger source of scrap material to then set off for further refining How are you making money on that? The other portion is that because they're so pretty, a lot of the chips will also simply get pulled and used as displays. The AL1, for example. These here, there are a couple of CPU collectors who prize the AL1 because of its, well, its legal and historical significance within the terms of what a microprocessor is and what a microprocessor is supposed to do. So they're quite prized as their own single chip solution. The other is that since there's so few machines left in functioning states, I would almost consider this an extinct platform, which is to say we are now running up into data that we can't reach. Even if we were able to make replicas of the custom chips using data sheets that we don't have, can you get to the software? I mean, 4-phase over the years had, for example, punch cards, which could be used for bootstrapping and diagnostics, and of course for user input. They had multiple densities of 9-track tape, and those would be using those Wanco tape drives. The tape drive which I received so weather damaged it wasn't reusable. You had other formats such as Diablo's disk drives, which use these packs here. This one's actually branded by Hewlett-Packard, but is used in many other systems, but they all use varying formatting, sectoring, soft sectoring, hard sectoring. There is solutions for something like that in that they are working on making a raw disk imaging tool. Forgotten Machines himself is actually working on that right now, so I'm very curious on what happens out of that. I need to find a Diablo drive and maybe I'll be able to recover some of that. Punch cards are easy. Magnetic tape is relatively easy. These packs, that's going to be a bit of work, but it may be resolvable within the next couple of years. And then, like I mentioned, with the NP-80 and the SMD controller using those large washing machine drives and disk packs such as this. Now we're running into serious problems where you need the drive, the proper drive with its proper cabling, the NP-80, the disk controller as to support everything, and then good packs. This here is still a complete unknown for everyone here. But what I'm trying to get across here is that in order for me to even make an attempt to get this last computer here running, or one of the last computers running, it's really close to wanting to work, but it still needs more work done to it. I'm asking you for anything 4-phase related. Internal memos, data sheets for various ICs, software manuals like software tapes, disks, pamphlets, really anything related to 4-phase at this point here. If it can be archived, I mean, it may be insignificant to people who want to use this on a hobbyist perspective because of how few there are, but to even make an emulated system that's 4-phase is going to require some of this information to make that possible, and I can only do so much. There are people out there such as BitSavers, Forgotten Machines, Jason Scott, I will use you as an example here. Like, they're all doing their hardest to archive what they can in the limited time we have left. I've been speaking to people who worked with 4-phase systems. They've been in this business, or they were working for a company 50 years ago. These were baby boomers. These are people, how old are they now? You may be lucky if in 10 years, many of them are still left. So I'm trying to acquire and learn as much as I can about the company in a limited amount of time. Even for boards, accessories, and cables, even photographs may very well be useful at this point. For every single piece of hardware that you saw in this video series, I have gone and I've taken front and back photographs of everything. They're all available on BitSavers right now. MITA was very nice to take a large quantity of schematics from 4-phase systems and scan them. Wiring diagrams, board layouts, trace routing. It's all available, or most of it is available online on BitSavers. There's some annual financial reports. There's the documentation for the disk operating system, the peripheral programming documentation. It's now all available online. To those of you who did initial scanning, thank you. To BitSavers, thank you very much for being able to go through all of those images, process them, and put them up. That's a lot of bandwidth, but I'm trying my best. And I will absolutely do my best to try and archive as much as I can. Like even this photocopier back here. Continuity-wise in future videos, this is probably not going to be here because I'm replacing this with a very large Fujitsu flatbed scanner and document feeder. I'm doing everything I can, and I can't do it all without help. Finally, I want to talk about something that I've been beating around the bush on since the beginning of the first video, where I was saying through the 1970s, four-phase systems saw almost uncontrolled success. Year over year, they were seeing record profits. Their shareholders and all their employees were very happy with where the company was going. And then in the 1980s, what happened? Well, it's worth pointing out that in 1979, when they were posting that, again, very profitable growth, Motorola released the Motorola 68000. Is the chip relevant to four-phase systems as a whole? No, four-phase was still doing fairly good. But Motorola had always been in the semiconductor business, and they were also now looking to get into the computing business as well. Now that they had their own 16 and 32-bit microprocessors, they themselves were already quite successful. In 1981, Motorola would agree to purchase four-phase systems for over $250 million in that time's money. That comes to about a little over $700 million today. The deal would be closed by 1982. But before the ink had even dried on that contract, was the fault in Motorola's hands that four-phase systems fell into obscurity? No. Motorola has been known to make its own mistakes, but four-phase systems got out at the right time. You see, in 1981, there was another product that came onto the industry which changed everything. Remember how I was saying IBM wasn't necessarily happy that four-phase was digging into their terminal and remote terminal business by supplying emulation for it, but needless to say, they still were able to let them make it. They were working on their own smaller office computers. I mean, there was the IBM 5100, the 5110, 5120, the 5233 Datamaster, which itself was a desktop machine. And 1 month after that Datamaster came out, another product came along which would change everything. I'm sure there are people who already know what machine I'm talking about. It's this computer right here from IBM. This is the 5150 personal computer. As an office device, you had a CPU, RAM, you had a video display, you had local processing, you could network it, you could connect to remote systems, you could do every single thing that a four-phase system could do, but now, instead of having a central computer and everyone having to use terminals, this was the future. One computer on everybody's desk. It was not a new idea. The microcomputer revolution had started up in the late 1970s, but IBM had managed to make a name for themselves, much like Apple does today, where when IBM does something, everybody else follows. So not long after, you would have PC clones, which would considerably make the PC platform cheaper, and it made stuff like four-phase hardware increasingly more obsolete. Motorola didn't drive four-phase into the ground at all. They bought in at the worst time, and they ended up with hundreds of millions of dollars in contracts, assets, unassembled machines, and technology, which for the most part wasn't profitable anymore. By 1983, 1984, things were beginning to look really, really grim for four-phase systems. By the middle of the 1980s, four-phase systems would shut down entirely and close their offices in Cupertino, California, being fully acquired and absorbed into Motorola themselves. Those who cashed out when they did ended up quite happy and quite profitable. Lee would go on to run smaller businesses and smaller foundations. Other employees would retire or move elsewhere in the semiconductor business if they didn't want to stay with Motorola. But what happened to that big prominent office right off the highway, De Anza Boulevard in Cupertino, California? Well, it's worth pointing out that if you go on Google Street View today and you go to that same general area, you will find that De Anza 2, or as it's now called De Anza 3, is still there. And it still looks exactly as it was when four-phase constructed that building 50 years ago. But the actual headquarters across the street, you're never going to find that again. For you see, in the late 1980s and in the 90s, that entire area of land was demolished and cleared, and in its place today, you'll find Apple's one infinite loop. I really hope you enjoyed this video series on four-phase systems. I hope I've done what I can to show off the hardware as good as I can. I couldn't demonstrate any of the software, but I've contributed a lot of photographs and what I could to documentation, which is now available online. And I've asked that if you can help with providing photos, documentation, or software, it would very much be appreciated. Thank you for watching, and until next time, have a good one.